Hey there, guys. So, in Unit 6 here, Unit 6 is going to be about momentum. And in our first target in Unit 6, we're going to talk about what momentum is. We're going to talk about how to calculate how much momentum is in an object's motion. That's our first target, to be able to calculate an object's momentum. And in the next target after this, we'll talk about the impulse momentum theorem. We'll solve some problems with that. In the third target in the unit, we'll talk about the conservation of momentum, and we'll talk about how to figure out an object's velocity after a collision with another object. That involves the conservation of momentum, and some different types of collisions. So let's get to talking about momentum. So let's talk a little bit about momentum here. So when I have to explain what momentum is, like in the simplest terms, I'm going to use the word oomph, right? The momentum, an object's momentum is kind of like the oomph behind its motion. Really technical term there. You could think about it like it's kind of like, how hard would it be to stop the object? If it would be difficult to stop the object, then it's got a lot of momentum. If it's not too difficult, then it doesn't have a lot of momentum. So think about for a minute, what kind of objects are going to be difficult to stop? Let's say we're talking about moving train. Is that going to be difficult to stop? Yeah, probably. Why is a moving train, even if it's not moving that fast, why is it difficult to stop? Because it's got a lot of mass. A lot of mass moving at not that much speed is going to be hard to stop, right? Say we've got a train moving along at 100 miles an hour. You know, you're not really going to put your hand in front of that and stop it. But opposed to that, let's say we're talking about a baseball moving along at 100 miles an hour. You know, in a baseball game, the man, he throws the baseball at like 100 miles an hour. And the catcher stands there, and with one hand, he stops the ball, right? So the big difference between the train and the baseball is that the train has a lot of mass. The baseball doesn't. But you could picture a baseball moving fast enough that it would be hard to stop. If you had a baseball moving the same speed as a bullet, that's going to be hard to stop. So, two things that kind of go into the momentum of an object are its mass and its velocity. And this is exactly how we calculate momentum. Momentum is the mass times the velocity. When we talk about momentum, we use a variable p, a lowercase p for momentum. And, every year people, they say, p for momentum. Why would you use p for momentum? And every year I was like, oh, I don't know, we just use p for momentum. I don't know why. But I got sick of people asking me, so one year I looked it up. And apparently the word momentum comes from a Latin word petere, which means momentum, right? So that's where the p comes from. It comes from Latin, right? So we use a lowercase p for momentum. And because momentum is the mass times the velocity, those are the units that we use to measure momentum, right? Mass is in kilograms, velocity is in meters per second, so momentum is in kilogram meters per second. So the variable is a p, the unit is kilogram meters per second. And you can calculate momentum by taking its mass times its velocity. One thing to note here real quick, because of an object's velocity can be a negative number, its momentum can also be a negative number. Okay, mass can't be negative. Mass can only ever be a positive number. But a velocity can be negative. If it's moving, in the negative direction, its velocity is negative. So if the velocity is negative, a positive mass times a negative velocity will give you a negative momentum. So, if you see a negative momentum, what does that mean? That just means that its velocity is in the negative direction. Right, so it is possible to have a negative momentum, and that means that the object's velocity is in the negative direction. Okay, so it is super easy to calculate an object's momentum, so let's go ahead and do it. Here we have an example problem. It says a 2,250 kilogram pickup truck has a velocity of 25 meters per second to the east. What is the momentum of the truck? Okay, so let's list the kind of things that they told us here. They told us that the pickup truck had a mass of 2,250 kilograms. Okay. They told us that its velocity was 25 meters per second to the east. Let's assume the east is the positive direction. So doesn't matter if it was the negative direction, then we would just get a negative momentum. It wouldn't make a big difference. Okay. So I know that momentum is mass times velocity. Let's put the numbers in there. And I'll grab my calculator and work that out. Okay, we're going to want two significant figures. So I got 56,250. I'll round that off to 56,000. And let me write it in scientific notation because it's kind of a bigger number. .6 times 10 to the fourth is 56,000. Okay, and then what units are we going to put on that? Since it's a momentum, it's kilogram meters per second. So easy, easy. Well, let's have just one more example here. This one says a 5.0 kilogram object has a momentum of 25.0 meters per second, or kilogram meters per second. What is its velocity? So this one is giving us the momentum, and it asks us to find one of the other things, right? So it tells us the momentum is, what was it, 25.0 kilogram meters per second. And it tells us that the object's mass was 5.0 kilograms. And it wants us to find the velocity. So let's take our equation. Momentum is mass times velocity. Let's put the numbers in there. So momentum was 25.0. Mass was 5.0 times velocity. Then we'll divide both sides by 5.0. And we need two significant figures. So 25 divided by 5 gives me 5. Two significant figures, I'll put a 0.0. And what units do we use for velocity? Meters per second. So there you go. Okay, so there was a little bit about momentum and a couple of example problems. Hopefully that helps us to be able to calculate an object's momentum. So until next time, take it easy.